Okay, are we ready to get started? Everybody got pictures of this that need it? We're good? Okay. So we are going to start talking about simplifying radicals and doing stuff with radicals. So on Friday, the very last thing that we did on Friday is we looked at this set of perfect squares. So in red, you are looking at perfect squares. 16 is a perfect square, and the square root of 16 is 4. 64 is a perfect square, and the perfect square of 64 is 8. You also say it by saying the square root of 64 is 8. Okay? 49 is perfect square. The square root of 49 is 7. So we are going to start looking for perfect square factors is what we're going to start looking for. Okay, so here we go. Here I have the square root of 8. 8 is not a perfect square. So if we check the square root of 8 on a calculator, we would get a decimal, and that would still be an approximation. So we have to break 8 down. And there is a perfect square factor inside 8. And that perfect square factor is 4. So what we do is we take 8, we leave it inside the square root, but we break it down to 4 times 2. Now, can we take the square root of 4? Yes. What is the square root of 4? 2. So I'm going to say 2 on the square root of 2. 2 on the square root of 2. Now, if we aren't able to look at 8 and say, okay, my perfect square factor is 4, so 4 times 2, I can do something called prime factorization. Prime factorization. Okay, prime factorization. Those are factor trees. Factor trees typically are things that students remember. So I take 8, I break it down to 4 times 2, and then I break the 4 down to 2 times 2. Remember factor trees? Okay. Those of you in early childhood education or elementary education, a factor tree is something that you might teach very late in middle school. And if you ever jumped up to 6th grade, you would definitely teach it. So now I have the prime factorization of 8. 2 times 2 times 2. So another alternative is to do the prime factorization. Then, do you see how I have a set of 2's inside? I take 1 out. So if I have 2 inside, because I'm taking a square root, I take 1 out. So then I get 2 on the square root of 2. That's how I do that. Now, we're going to jump over to the square root of 45. The square root of 45 has a perfect square factor. What is that? I heard it. 9. 9 times 5 is 45. What is the square root of 9?
3.
Good. So then I have 3 on the square root of 5. Now, it's okay, especially as we start dealing with larger numbers, if you aren't able to identify that perfect square factor. What you do then is you do your prime factorization. So I have 45, that's 9 times 5. Square root, and then we've got 3 times 3. So my prime factorization is 3 times 3 times 5. Prime factorization means that you are breaking a number down as to the smallest number that you can. 3 does not break down any further. It's 1 times 3. That's it. So the prime factorization of this is 3 times 3 times 5. And that's inside a square root. I have a set of 3's inside the square root. So I'm going to pull 1 3 out. So then I write it as 3 on the square root of 5. And you can do that either way. Either way is completely fine. Okay? Yes, ma'am.
So you saying we put the 5 on the outside?
You do not put the 5 on the outside. You would have to have another partner. 5 would have to have a partner on the inside to pull it out. Okay? So you've got to keep that 5 on the inside because it only showed up once. The reason that you pull the 3 to the outside is because it showed up twice. Okay? Can I go to the next screen? Okay. Now, these are cubed roots. These are cubed roots. You're not going to deal with them as much, but I just want to expose it to you. I just want to expose you to it. Okay? When you are doing cube roots, it has to show up 3 times when you do prime factorization. It's got to show up 3 times. So when I break 24 down, okay, I'm going to break it down to 8 times 3. At some point, you might recognize 8 as a perfect cube. 2 times 2 times 2. But if you don't, that's okay. You can still break it down. I've got 4 times 2, and then 2 times 2. So my prime factorization for 24 is 2 times 2 times 2 times 3. And because of this 3, guess how many 2's I have to have in order to pull 1 out? 3. So I've got 1, 2, 3. So I only pull one of those 2's out because it is a cubed root. Okay, so that's a cubed root. Now, 54, you might be like, oh, 54 is even, so 27 times 2. You might be able to realize that. And 27 is a perfect cube. 3 times 3 times 3 is 27. So your answer here is 3 on the cubed root of 2. Most of us can't look at that and see that. And that's okay. Most of us can't look at that and say 27 times 2. Okay? If you can, great. If you can't, that's okay. So what we're going to do is we're going to take the prime factorization of 54. So I'm going to say 9 times 6. Is 9 times 6 54?
Yes.
Yes. Then 9 breaks down to 3 times 3. 6 breaks down to 2 times 3. So inside my cubed root, I'm going to have 3 times 3 times 3 times 2. 3 times 3 times 3 times 2. Because this 3 shows up 3 times inside the cubed root, what do I bring out? Good. Okay? So you can do it either way. Okay? You can do it either way. Especially for cubes, students almost always go back and do the prime factorization, especially for cubes. Now, what I'm going to do now is I am going to give you 3 minutes to do these 3. Okay? 3 minutes to do these 3. Okay. So I've really written down both ways, and it's completely fine. You can do these either way. So for the square root of 50, a lot of times students can identify that 25 times 2 is 50. Okay? And if you did, that's fine. What's the square root of 25? 5. Okay? So that 5 goes on the outside. That 5 goes on the outside. And so my final answer here is 5 on the square root of 2. This is my final answer. Now, if you were not able to identify that 25 times 2 is 50 and you needed to do the prime factorization, 5 times 5 times 2 is the prime factorization. So here, do you see how I've got 2 5s right there? What do I pull out? 1 5. If I've got 2 on the inside, I pull 1 out. Okay? So I am left with 5 on the square root of 2. Is that the same thing? Did I get it? Did I get the same thing for both? And that's completely fine. You can do it either way. Now, 3 times the square root of 80. Breaking 80 down to 16 times 5 is something that students miss sometimes. Okay? So it's okay if you didn't see that 16 times 5 was 80. Students typically see that 4 times 20 is 80. The problem with doing 4 is not the largest perfect square. Okay? 4 times 20 does break it down into a perfect square, but you didn't get the largest perfect square. So again, if you do the prime factorization, if you take 80 and you break it down to 8 times 10, 8 breaks down to 4 times 2, and then 4, 2 times 2. So you've got your primes. 10 breaks down to 2 times 5. So 2 times 2 times 2 times 2 times 5 equals 80. Now here, I've got a set of 2's here, and I have another set of 2's here. So that means I'm going to bring out 2 2's. I've got to bring a 2 out for each set. So then on the outside, I'm going to have 3 times 2 times 2 on the square root of 5. 3 times 2 is 6, times 2 more is 12. So I have 12 on the square root of 5. So this is your final answer. Now, if you broke 80 down into the perfect square of 16, then you take the square root of 16, which is 4, and I would say 3 times 4 on the square root of 5. Did I get the same thing regardless of which way that I did it? Did I get the same thing? Now, my next question. What's the difference between this 3 and that 3? What's the difference between those two 3's? What's happening in those two 3's?
The one on the right is cubed.
Okay, the one on the right is the cubed root. Okay, you're taking the cubed root of 108. What's happening to the one on the left? Multiplying. Excellent, excellent, okay? So you've got 3 times the square root of 80, or you've got the cubed root of 108. So kind of look at that and see where it is. The perfect cube factor in 108 is 27. And the cubed root of 27 is 3. Now, it's much harder to find those perfect cubes than it is even the perfect squares. Okay? So the prime factorization really is more helpful when you're doing perfect cubes. So I've got a set of 3 3's. 3 times 3 times 3. Because I am looking for the cubed root, that's why I have to have a set of 3. So I'm going to pull the 3 on the outside, keep my cubed root, and I'm left with 4. Why can't I pull out this? Why can't I pull out one of the 2's? because it's cubed root. Okay, it's not the square root. Okay? Can I move off that page? We good? Okay. I'd like you to look up here at the board. A lot this semester you have heard me say, you can't have a 0 in the denominator. When I have a 0 in the denominator, this number is undefined. It's not real. It's not possible. This right here does not exist. Okay? What I'm telling you today is for a fraction to be simplified, you can't have a square root in the denominator. Now this, I'm telling you, this is not real. So you'd have to put your undefined. What I'm telling you about this is that it's not simplified. Okay? This right here is equivalent to what we call the null set. It's just undefined. It's not possible because we've got a 0 here. Here, what I'm telling you, when I say you can't have a square root in the denominator, what I'm telling you is that this is equivalent to 2/4, or it's the same idea as 2/4. What is 2/4 simplified? 1/2. So I have to take 2/4 to 1/2 before it's simplified. So that's what I'm saying about the square root of 2/3. It's not simplified. It's still a real number. We just haven't simplified it. So that's what we're going to focus on. So it's similar to this idea right here. Okay. So the first thing that you need to know is that if I have the square root of the fraction 2/3, that is the same thing as the square root of 2 over the square root of 3. Okay? So the square root of 2/3 is the same thing as the square root of 2 over the square root of 3. Now, the way that I can get rid of this square root of 3 in the denominator is that I multiply it times the square root of 3. So the square root of 3 times the square root of 3 is the square root of 9. And what is the square root of 9? 3. Okay? Now, I can't just randomly multiply something by the square root of 3. In order to keep it equivalent, what's the only thing I'm allowed to multiply by? 1. I'm only allowed to multiply by 1. So if I multiply the bottom by the square root of 3, I have to also multiply the top by the square root of 3. Okay? Now we've already determined that the square root of 3 times the square root of 3 is the square root of 9, which leaves us with 3. What's the square root of 2 times the square root of 3? Square root of, you got it. Okay? Now, if you remember, if I was making equivalent fractions, or I was trying to find a least common denominator, if I had something like 1/2 plus 2/3, my least common denominator would be 6. 2 goes into 6 how many times? 3. So then we have 3 times 1 is 3. What I've done here is I've multiplied this by 3/3. 3/3 is 1. Here I multiplied by 2/2. 2/2 is equal to what? 1. So square root of 3 over the square root of 3 is also equal to 1. So that is what we are doing here. Now, your next question is, can this be simplified further? Now, this is something my students have struggled with for years. For many, many years. They think because this right here, you've got the square root of 6 is divisible by 3, that you can divide these two. You can't. The reason that you can't is because the 6 is inside a radical And the 3 is what? Is there a radical with the 3? No. So you can't divide those. If they were both inside a radical or both outside a radical, you could combine them. But if one's in and one's out, you can't. You can't. Okay? So let's look at the next one. What am I going to multiply the top and the bottom by here? Square root of 8. So the square root of 8 over the square root of 8. Okay? The square root of 5 times the square root of 8 is the square root of 40. Okay? What's the square root of 8 times the square root of 8? 8. Now, can this be simplified further? The answer to this one is yes. There is a perfect square inside 40. What is the perfect square inside 40? What times 10 equals 40? Is 4 perfect?
Yes.
Yes. What's the square root of 4? 2. So now I have 2 on the square root of 10 over 8. 2 on the square root of 10 over 8. Now, I've got a 10 on the inside and an 8 on the outside. So I can't do anything. It doesn't matter that this 10 and this 8 are both divisible by 2. Because this is on the inside and that is on the outside of a square root. But do you see this 2 right here? It's on the outside. Is that on the outside? Yes. So you can think of this as 2 8s. What goes into 2 and 8? 2. Okay? Because they are both outside, you are allowed to do that. Okay? So 2 goes into 2 one time, and 2 goes into 8 how many times? Good. So my final answer here is the square root of 10 over 4. Square root of 10 over 4. Now, I'm going to give you one to do on your own. You ready? Okay. You are going to do this one on your own, and I'm going to give you 1 minute to do it. But I am going to tell you, you only have to multiply by the square root. The 5 is okay. We're not trying to get rid of the 5. What are we trying to get rid of? Just the square root of 3. So we're going to multiply by the square root of 3 over the square root of 3. And I'm going to give you 1 minute to work on that. Leave this 3 on the outside. So this becomes 3 times the square root of 2 times the square root of 3. Okay? I am multiplying the 2 and the 3 together because these are both on the inside. This 3 we leave alone because it's on the outside. Now, in the denominator, I am multiplying 5 times the square root of 3 times the square root of 3. So in the denominator, we end up with the square root of 3 times square root of 3, which is the square root of 9. So what does that simplify to? 3. Okay, so that is 5 times 3. Do you notice I've got a 3 on the top and a 3 on the bottom? And that's okay. So my final answer here is the square root of 6 over 5. I can cancel those two 3's because they're both outside. Now, if you multiplied, so you may have multiplied at this step right here. You may have had 3 on the square root of 6 over 15. That's okay if you had that, because then you identify that it's the square root of 6. Okay? You're still taking the 3 out and simplifying it. Okay. Now, what we are going to do next is we are going to do some multiplying. And you've already done a little bit of multiplying here. So we're going to do some more multiplying. When you are multiplying radicals, what you have to understand is you multiply the numbers that are on the outside, then you multiply the numbers that are on the inside. They can't cross over to each other. Okay, so the first thing that I'm going to do is I'm going to multiply my 2 times my 3. What is 2 times 3? 6. Then I'm going to multiply the square root of 3 times the square root of 5. What is the square root of 3 times the square root of 5?
15.
Good, and so that is the square root of 15. Then you always, always, always ask yourself, can this be simplified further? You always ask yourself that. Can this be simplified further? This one cannot, because the only thing that 15 breaks down to is 3 times 5. And that's not, neither one of those are perfect. So that's the only thing it breaks down to. So here, we're going to do the next one. I am going to multiply 7 times 3. What is 7 times 3? 21. Then I've got the square root of 6 times the square root of 8. What's the square root of 6 times the square root of 8? 48. Okay. Then I ask myself, can this be simplified further? This can be simplified further. 48 has a perfect square in it. What is the perfect square? Okay, 24 is not perfect. Okay, and 2 is not perfect, so it's not 24 and 2. I heard it. What is it? Okay, 6 and 8 are not perfect. 6 times 8 is 48, but 6 and 8, neither one of those are perfect. So we're looking for one of these red numbers, 4 and 12. So let's talk about what happens when we do 4 and 12. So I'm going to do that over here on the left. So I've got 21 times the square root of 4 times 12. What's the square root of 4? 2. So I have 21 times 2 on the square root of 12. What's 21 times 2?
42.
So I have 42 on the square root of 12. Now, does 12 break down to something perfect?
Yes.
It does. What does it break down to? 4 and 3.
4 and 3.
So then I have 42 times 4 times 3. What's the square root of 4? 2. So I have 42 times 2 on the square root of 3. So 84 on the square root of 3 is my final answer. Now, there's a couple of ways that we could have avoided this, because we've got an extra step in here, because our 4 was not our largest perfect square. There is a larger perfect square in here, and it is 16. So 48 breaks down to 16 times 3. What's the perfect square of 16? Or what is the square root of 16? 4. Okay, so then I have 21 times 4. And then I end up with 84 on the square root of 3. So this is the most efficient way to do it right here. However, we don't always identify that 16 is the largest perfect square in 48. Okay? Oftentimes, students will find the 4. And as long as you keep going at this point, you're fine. But you just have to be sure that you keep going. Okay? Now, if you're not sure you're going to get the biggest perfect square, then I would do the prime factorization. So I would do 48 breaks down to 24 times 2 and 8 times 3 and 2 times 4 and then 2 times 2. So I've kind of ran out of room here. So I have 21, 2 times 2 times 2 times 2 times 3. I've got 2 sets of 2s. I pull a 2 out for each set of 2. So I'm going to have 21 times 2 times 2. Does that get me to the same place? It does. So these are 3 different ways, and as long as you keep going in any of them, then you get the exact same answer in any of them. So you're okay. Okay? Any questions about that? Okay. Now, the last thing that we're going to do today is the distributive property. And I do want you to be sure that you're writing these steps out because that's going to be helpful to you. So we are taking the square root of 3 and we are multiplying it times the square root of 6. Then I'm taking the square root of 3 and I'm multiplying it times the square root of 12. So I have the square root of 3 times the square root of 6 plus the square root of 3 times the square root of 12. Square root of 3 times square root of 6 is the square root of 18. Square root of 3 times square root of 12 is the square root of 36. Okay? Can 18 be broken down?
Yes.
Good. Okay? 18 breaks down to 9 times 2. The reason I picked 9 times 2 is because 9 is a perfect square. If I had picked 6 times 3, I wouldn't have gotten anywhere. 6 isn't perfect and 3 is not perfect. So I needed to pick 9. What's the square root of 9? 3. So I have 3 on the square root of 2. Can I take the square root of 36? What's the square root of 36? 6. Okay, now, you want to think of this as 3x, it's similar to 3x plus 6. Can I combine 3x plus 6? No. 3 on the square root of 2 plus 6, those are not like terms either, so you cannot combine them. This is my final answer. Okay? I thought I was about to sneeze. I'm sorry. Okay. Again, we're going to distribute this. So I have 2 on the square root of 2 times 4 on the square root of 3. Then I've got a subtraction right here. 2 on the square root of 2 times 5 on the square root of 6. So again, I multiply my 2 and my 4 because they are both outside. Then I multiply the square root of 2 and the square root of 3. 2 times 3 is 6. They are both on the inside. Okay? Now I'm going to do 2 times 5. What's 2 times 5? Then I have the square root of 2 times the square root of 6. The square root of 2 times the square root of 6 is what?
12.
Good. Oops. Now, we know, because we've done it before, that the square root of 12 can be broken down. There is a perfect square factor inside 12. What is it?
4 and 3.
Good. So 12 breaks down to 4 times 3. What's the square root of 4? 2. So my final answer here is 8 on the square root of 6 minus 20 on the square root of 3. Okay? That's my final answer. Now, you've got kind of your schedule. Now, we're going to finish up this chapter on Wednesday. We'll probably have a quiz on Friday over chapters 7 and 5. We'll go back and do that linear stuff. Here is your homework. I would get as much of this done. Whoops. Where are we? There we are. I would be sure that you have a picture of this. I would make sure that you've got it. And that you get as much of that homework done as you can. Okay? I will see you on Wednesday.